Welcome, finance professionals. Today, we are diving into the hidden plumbing of the financial world, domestic clearing and settlement ecosystems. Understanding how money actually moves is critical for any treasury leader. Let us get started. Welcome to our first slide. As a senior treasury professional, you must master the difference between clearing and settlement terms often incorrectly used interchangeably. What exactly are they? Clearing is the end-to-end data process, the receipt, transmission, reconciliation, and confirmation of a payment order. Settlement, on the other hand, is the actual, final transfer of funds that discharges the obligation. The basics involve banks passing data files first and moving actual cash second. Why is this distinction crucial? Because clearing handles the information, but settlement handles the financial risk. How does it happen? Financial institutions use highly secure domestic networks to exchange this data. For our deep dive, consider netting. During the clearing phase, thousands of transactions back and forth between two banks are mathematically netted out. So, instead of making thousands of settlements, the banks only make one final net settlement transfer, saving immense time and liquidity. Looking at this simple flowchart, you can see the journey of a payment. On the far left, the payer initiates the transfer. This flows directly into the pink node, the clearing phase. Here, the banks are simply talking to each other, reconciling data and netting amounts. No real money has moved yet. Once the data is confirmed, it moves to the blue node, the settlement phase. This is where the actual funds are irrevocably transferred between the bank's reserve accounts, eventually reaching the payee on the right. Moving to slide 2, let's look at the heavy artillery of domestic payments, real-time gross settlement, or ARTGS. What is ARTGS? It is the system used for high-value, time-critical transfers. The basics are in the name itself. Real-time means the payment happens immediately. Gross means the system does not net payments together. Every transaction is settled individually. If Bank A owes Bank B $100 and B owes A $60, ARTGS executes two separate settlements. Why use this? Because it completely eliminates settlement risk for massive corporate and interbank transactions. Once it hits, it is final and irrevocable. How does it work? These systems are typically run by the country's central bank. The central bank debits the sender's reserve account and credits the receiver's instantly. In our deep dive, the trade-off for this zero-risk environment is high liquidity requirement. Because payments aren't netted, banks must hold massive intraday liquidity balances to fund these continuous, individual outflows. This diagram illustrates the immediate nature of an ARTGS transfer. The corporate treasury at the top sends a high-value wire instruction to the sender bank. This flows straight into the central diamond, the central bank's ARTGS system. Notice that the central bank handles this as a gross instruction. It performs an immediate debit to the sender bank's reserves and an immediate credit to the receiver bank. The funds instantly flow down to the counterparty account. There's no waiting, no batching, and zero settlement risk. On slide 3, we examine the entity holding this ecosystem together, the central bank. What is its role? The central bank is the ultimate pivot point, acting simultaneously as the system operator, the regulator, and the liquidity provider. The basics are that the central bank holds the master reserve accounts for all commercial banks. Why is this necessary? Because when major banks settle billions of dollars between each other, they need a 100% risk-free environment. Central bank money cannot default. It is the safest asset in the domestic economy. How do they support the system? They administer the infrastructure and inject credit. For our deep dive, consider the central bank's role as the liquidity provider of last resort. If a commercial bank has massive outgoing ARTGS payments, but is waiting for incoming funds, the central bank provides daylight overdraft limits intraday credit so the bank can keep processing payments without grinding the entire economy to a halt. This mind map places the central bank squarely at the center of the ecosystem. Branching out, we see its three main functions. To the left, it acts as the regulator and overseer, ensuring systemic stability. In the middle, it is the ARTGS system operator, actually holding the commercial bank reserve accounts where settlement takes place. On the right, it acts as the liquidity provider, explicitly providing daylight overdrafts so that the gross settlement system never freezes due to timing mismatches. Slide 4 shifts our focus to high-volume operations, the Automated Clearing House, or ACH. What is ACH? It is an electronic network designed specifically for high-volume, lower-value payments. The basics contrast sharply with ARTGS. Instead of real-time gross settlement, ACH groups thousands of transactions into batches, clearing them at scheduled intervals and netting the totals. Why do we use it? Pure cost efficiency. If a corporation tried to run 10,000 payroll payments through an ArcGIS wire system, the transaction fees would be astronomical. ACH costs pennies per transaction. How is it executed? A treasury system generates a bulk file containing thousands of instructions, sending it to the bank. The ACH operator sorts the data and routes it appropriately. In our deep dive, ACH has a unique superpower. It supports pull transactions, also known as direct debits. This means your treasury can automatically pull subscription payments from a customer's account on a specific date, heavily optimizing your cash inflows. Here we visualize the efficiency of the ACH batch process. Starting on the left, the Treasury ERP sends a single bulk file of instructions to the originating bank. This bank performs a batch upload to the central ACH operator. Instead of immediate settlement, the ACH operator spends time sorting and netting thousands of mixed instructions. It then forwards the categorized batches to receiving Bank 1 and Bank 2. Finally, the funds are distributed to the individual employee and vendor accounts on the right. High efficiency, low cost. On slide 5, we address the realities of daily treasury execution, critical operational nuances. What are these? They are the strict timing and credit rules that govern the clearinghouse. The basics involve managing your daylight overdraft limits, respecting system cutoff times, and understanding value dating. Why must a senior treasurer obsess over this? Because missing a central bank cutoff time by 1 minute means your multi-million-dollar payment settles tomorrow. This causes failed M&A settlements, delayed payroll, and massive reputational damage. How do we manage it? Modern treasury management systems are programmed to queue and release payments optimally, matching incoming cash with outgoing obligations to stay within intraday limits. For our deep dive, let's talk about dating. Processing a payment does not guarantee usability. The value date dictates when the beneficiary can actually earn interest on the funds. Understanding whether a payment clears on cash date today, TOM date tomorrow, or spot date 2 days is crucial for accurate cash forecasting. This sequence diagram walks through the operational timing constraints. The corporate treasury approves a payment run. Instantly, the TMS performs an internal check on intraday limits and assigns the correct value date. Step 3 is critical. The TMS releases the instruction to the clearing bank before the strict 15:00 cutoff time. The bank sends an acknowledgement. Look at the warning note at the bottom. If that system had released the file at 15:01, the payment would be pushed to the next business day, severely disrupting the company's financial supply chain. Slide 6 tackles the technological backbone of modern clearing, API, and automated connectivity. What enables this ecosystem? The seamless integration allowing your corporate ERP to talk directly to the domestic clearing network. The basics revolve around straight-through processing, utilizing global standards like ISO 20022 XML. Why do we demand this? Because manual intervention in payment processing introduces unacceptable latency, keystroke errors, and fraud risk. How is it built? Treasuries deploy APIs or host-to-host connections. Look at our sample code concept on the screen. This JSON payload represents an API call pushing an instruction. It clearly defines the unique ID, dictates that it must route through the cost-effective ACH clearing system, sets the exact amount, and mandates the value date. In our deep dive, remember that integration is a two-way street. Advanced treasuries use API webhooks to receive real-time status updates the millisecond a payment clears, allowing the system to instantly auto-reconcile the general ledger. Here we map the straight-through processing tech flow. The ERP at the top generates an API payload and sends it to the TMS gateway. The TMS translates this into the standardized ISO 20022 XML format and pushes it to the bank server. The bank server's logic engine makes a routing decision based on urgency and value, sending it either to the ArcGIS system or the ACH system. Upon successful clearing, the system fires a real-time webhook update back up the chain to automatically update the ERP. Complete, touchless automation. Let's apply these concepts in a real-time use case on slide 7, optimizing payroll and vendor flows. The scenario: a rapidly growing corporation is bleeding cash on bank fees and suffering liquidity traps. The problem: they were using expensive, urgent ArcGIS wires for everything, including routine payroll and supplier invoices. They were paying $15 a transaction when they should have been paying pennies. How did the treasurer fix this? By stepping in and implementing a payment factory model that migrated all routine flows to the domestic ACH network. The execution, the TMS was reprogrammed with routing logic. High-value, time-critical flows like an M&A settlement still use ArcGIS. But the 5,000 monthly salary and vendor payments are now batched into an ACH file and sent 2 days prior to the required value date. The result? Operational brilliance. The firm slashed transaction costs by 95%, eliminated manual entry errors, and maximized interest yield because cash stays in the corporate account right up until the exact value date. This flow shows the decision engine of our use case. Raw payment data enters the TMS routing logic diamond. The system evaluates the parameters. If the payment is over $1 million or tagged as urgent, it takes the top path, ArcGIS wire, accepting the high cost for instant clearing. If the payment is routine and under the threshold, it takes the bottom path, ACH batch file, enjoying low cost and scheduled 2-day clearing. Both pathways intelligently converge to create a highly optimized treasury. Finally, on slide 8, we look to the future of domestic ecosystems. What is on the horizon? The rapid migration toward 24/7/365 real-time retail payments and AI-driven clearing networks. The basics are changing. New systems like FedNow in the US or UPI in India are blurring the lines between slow batch ACH and expensive ArcGIS. Why is this happening? Because the modern digital economy demands instant liquidity and always-on commerce. Traditional weekend and holiday clearing blackouts are no longer acceptable. How are networks adapting? Central banks are overhauling infrastructure and deploying AI machine learning nodes to perform fraud and anomaly detection in milliseconds before clearing a payment. As a treasury leader, you must master these domestic clearing concepts to optimize your firm's working capital, slash banking fees, and ensure operational resilience. I want to invite all learners to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep. At quicktechie.com, you will find comprehensive Q&A banks, full ebooks, audiobooks, full-length training, and interview guides to elevate your treasury career. Thank you for joining me. Our final diagram charts the evolutionary roadmap. We begin at the top with legacy systems, which are currently being upgraded via a universal ISO 20022 adoption. This standardization paves the way for 24/7 instant payments. Because instant payments require instant security, this flows into AI anomaly detection. All these advancements culminate in the ultimate destination highlighted in green, the 2030 Clearing Ecosystem, a continuous, intelligent, and instantaneous financial network. Thank you for watching.